Welcome to module 20 of Database Management Systems course in the IIT Madras online BSc program. We have been discussing logical database design, conceptual design issues using entity relationship model, and in the last module we have discussed the ER diagram representation and how simple ER diagrams, ER models can be translated to relational schema. In this concluding module on the topic, we will discuss some more extended features of the ER model and give a glimpse of some of the design issues and considerations. So, these are the two things to discuss primarily. So, extended ER features, we will discuss a couple of them. The first is we have mentioned already that relationship sets are mostly binary, but at times it may be convenient to represent a relationship as non-binary, like here is a ternary relationship between project, instructor and student, right, the guide. So, it says that for a student what is the project and who is the instructor. This is a triplet combination which is kept in this relationship, which is ternary. Now, there are couple of questions here. One is the question is what could be the cardinality constraint. For example, if I go back to the previous, say if I say this, then what does that mean? That means there can be only one instructor, right? That is a uniqueness. Or if I say that, which means only one student can work in the project, right, and so on. The question is if we say what does it uniquify, which one is one or which combination is one. So, that is the basic problem. So, if you look in a little abstract terms, then if I have a ternary relationship between A, B and C with arrows to B and C. So, I have A, I have B, I have C and I have R. So, this and this. Okay. Now, if we have arrows to B and C like this, what does that mean? That each entity A is associated with a unique entity from B and C, could be one meaning. Other meaning could be that each pair of entity A B is associated with a unique entity C, or and each pair of A C is associated with a unique entity in B. You can give any of these interpretations, right. So, there is some kind of ambiguity when you have more than one arrows, and in different formalisms through the development time, all these alternatives have been used by someone or the other, but it creates confusion. So, we will outlaw the use of more than one arrow if it is a non-binary relationship. Okay. So, this is a ground rule to follow. Next, let us talk about ISA relationship. I am sure most of you have heard about ISA or specialization generalization relationship. So, this happens is when there is you have an entity set. So, if we look at top down, we have an entity set, and from that entity set we have a specialized low level entity set that may have additional attributes and or that may be participating in relationships in which the higher level generalized entity set does not participate. So, we typically show this by a triangle component in the ISA, and attributes have an inheritance. So, let me go to the example, it will become clearer. So, this is kind of the highest level or the root entity set, the most generalized. Then what I say by this arrow I mean ISA. So, we will read and textually write this in this way. Student is a person. So, which means that student will have all the attributes inherited from person. So, from higher to lower you will have all the attributes inherited, right. Similarly, employee is another specialization which has all the attributes inherited from person, but in addition it has its own attribute salary. Student has its own attribute total credits. Now, if you look at instructor, so instructor is a employee, employee is a person. Okay. So, the instructor inherits all attributes of person which is already there in employee, and the additional attribute of employee. Instructor will inherit all of those, and it adds one of its own which is rank. Similarly, for the secretary and so on. So, this is how the hierarchy works, and it is important in multiple ways. One is it is giving a different form of identifying notion to the entities, and obviously employees will engage in variety of relationships where students have no role, and students will engage in a variety of relationships where employees may not have a role. Whereas, in general a person will engage in some general activities. So, there when you do specialization there could be couple of different situations. One is overlapping, which is kind of inclusive situation. For example, employee and student is overlapping, that is an employee can also be a student or a student can also be an employee, right. So, it is possible that some person entity exists in both, but instructor and secretary are disjoint. No instructor can be secretary or no secretary can be instructor. So, an employee cannot be both an instructor and a secretary. Then the question is whether this inheritance is total or partial. That is, given any generalized set, is it necessary that all entities in that set exist in at least one specialized entity set, which if I read in terms of person here says, is it necessary that every person has to be either an employee or a student or both, or could I have a person who is neither an employee nor a student, just a person, right. So, if it is allowed, if my design allows that it is not necessary for every entity in the higher entity set to be necessarily be a member of one or more lower entity set. If it is not mandatory, then the inheritance or specialization is partial. If it is mandatory, it is total, right. So, this is kind of the notional modeling. So, this notion exists very strongly in several domains, particularly if you have done any object oriented analysis design, you have used Java, C++, you must have come across this specialization, generalization, class, subclass, parent class, child class concept. So, it is just a parallel of that, and this is the representation of that information in the ER model. So, the question is again the related question, how do we represent it in the relational schema? There could be two ways, of course. One is I represent the higher level entity, and for the lower level entity, which is specialization, I use the key of the higher level entity, so that I can anytime get the other attributes of the higher level entity, and put the attribute of the lower level entity. So, what we are doing is person is at the root. So, I describe everything for the person. For employee, I just use ID, which is basically the ID coming from the person, and the total credit, which is the additional one. Similarly, for the employees. Right. So, this could be one way. So, the advantage here is you do not have the problem of redundancy, anomaly, all these, but it is the flip side is whenever I want to get say for students total credit, naturally most often I would also need to know the name, right. So, any reporting will need the name. So, to get the name I have to go to another entity set, which means that I have to go to another table, which means that I have to do a join and so on, right. So, expensive. So, the other could be you do a flatten out design, that you simply just do the inheritance and borrow. So, person has everything. In student, the low level one, you take all the attributes of the person you are specializing from and add the like this. So, the advantage here is you know, you do not have to traverse between relationships, between entities or between relations. So, it will be a lot more efficient to do, but a little flip side is that if some student is also an employee, or rather an employee is also a student, then there will be two entries here, right, naturally, which is so there will be duplication of name, street, city. The higher level entity sets attributes will be duplicated for those cases. So, in overlapping case you will have some redundancy and potential anomaly. Now, this is a reality of the modeling. So, you cannot say which one is that way better. It depends somewhat on what your application, particular application is, how often you see that the join will be required, or how potential is the threat of anomalies happening, and whether you can take care of those through constraints or through application programming, and decide on which method of translation to relational schema you would prefer. Now, this was specialization coming from top to bottom. You can do the other, you can go from bottom to top, which is called the generalization. That is, you have two entity sets which have significant stuff in common. So, take that common part, make it at a high level entity set and go in the generalization way. Basically, one is the inversion of the other. Specialization and generalization, one is concept wise it is the same, and they are used interchangeably, the terms are used interchangeably, and you could keep on going like this. There may be a little difference in terms of the completeness constraints, because for example, if you have done bottom up, now what will be the completeness in general? In general, the completeness is partial. If you do not know, then you do not know whether a higher order entity set has all entities represented in any of the lower order entity sets. Right? It may be, it may not be. So, it is partial. Now, it will be total if you have certain real world condition to think that it will have to be total, right. But if you do bottom up generalization approach, then you are basically taking union, right. So, if you are taking union, then anything that you get on the higher order entity set has come from one of the lower order entity sets, right. So, it tends to be, if you do a generalized higher level entity set through the bottom up approach, then it tends to be total, but it is not advisable to just go by that and do the analysis of the requirements to say if it is total. So, for example, if I say that the students have I am sorry, say I have two kinds of students, UG and PG. Right. Two other specialization of student, UG and PG, and we will have attributes for that. Now, I can say the student is total in this specialization, because every student has to be either an undergraduate student or a postgraduate student, because that is how you become a student, right. So, just try to understand that it is not just thinking of a unification or generalization in the schema. It is the reality that you have to check on is how do you become a student. You become a student by either enrolling for the UG or enrolling for the PG, right. Otherwise, you are not a student. So, if somebody is a student, it becomes imperative that that person has to be either an undergraduate student or a postgraduate student. So, this relationship will be total in the aggregation. So, we can mark this by a dashed line and write total. That is the notation that ER diagram specifies, which says that this specialization goes total in that way, right. So, that is the notion of total and partial. These are things that we may use subsequently. Let us next talk about aggregation. Yeah. Now, think about the project guide ternary relationship. Now, we need another relationship, which is the evaluation. So, the project will be evaluated. So, we introduce another relationship eval for, which is between project, student and instructor. So, you can see that both of these eval for and project guide, they have overlapping information, they have redundancy, because every eval for relationship corresponds to a project guide relationship, right, because it cannot be that I am evaluating x, y, z, this triplet, whereas in the project guide it is x, y, w, that cannot happen, right. So, eval for in a way corresponds to the project guide relationship, but I cannot just have eval for and remove the project guide relationship, because there may be some projects which are not being evaluated. So, they will not have an eval for entry. Okay. So, this is a kind of redundancy which cannot be resolved at this level. So, what is introduced here is a concept of a abstraction of a relationship into an entity, that through this relationship the entire thing can you look at as an entity. So, this is how you represent that. You are saying, just see carefully, these are the things we had, and we have put an enclosing box. This enclosing box says that this whole thing together, the project guide, is an entity as well, can be treated as an entity. If it is, then for that I have an evaluation. So, now it is not necessary that every project guide entry has to have an evaluation, but I will have an evaluation for a particular project guide situation, project guide entry, right, project guide, which means basically student instructor project combination, which will have an associated evaluation. So, I am looking at it a little differently than just having a decomposed view of two different ternary relations. This removes the redundancy, makes the whole concept clearer and allows me to model in a better way. So, when it comes to representation, the schema is, I am sorry, there is a typo here. I am sorry. This is not there. This text is not there. It is kind of a LaTeX command which somehow has crept in. So, the name is eval_for, as you have seen. So, to represent the aggregation and create a schema containing the primary key of the aggregated relationship, because I will need that. I need the primary key of the associated entity set, that is evaluation, and if I need any other additional descriptive ones. So, primary key of the project ID relationship are these three, coming from 3 entity sets, and for the evaluation, this is the evaluation ID. There could be other auxiliary ones which were. So, this whole eval_for will be represented in this way, so that the schema project guide can now be made redundant. So, that was so before we close, let us discuss a few design issues. Obviously, there is always a question of what is an attribute and what is a entity. Right? They are interchangeable in a certain way. For example, in phone number, the phone number could be an attribute. If it is an attribute, it is necessarily single valued. If you want it to be multi-valued, you will have to make it an entity and connect it to a relationship, as we have seen. So, these are considerations which will be. There is always a trade off in terms of what is entities and what are relationships. Right. We already have seen some of that earlier in terms of our instructor, course and student department, instructor, student and department between them, that whether we need those relationships or not. So, these kind of so you will have to see that if things are total, for example, these are registration which is going through a registration section registration and student registrations. The section registrations gives the registration information of the section, student registration gives the information to the student, and do you really need these relationships, or you can just convert it into a single entity relating the section with the student. So, these are considerations which we will go through. The other, as I said, that most relations in the database design are binary, and but there are situations when you have non-binary relationships. Right. It may be more natural to think about it in that way. For example, you have the parents relationship. Parents relationship is ternary because you have two parents. So, there is a person, there is a father, there is a mother. So, it is a ternary 3-way relationship. But this kind of a relationship is very easily decomposable in terms of binary relationship. I will have two relationships, because they do not, I mean, there is no that way relationship between father and mother. The relationship is between the person and the father, person and the mother. So, it can be two independent relationships. Right? That two binary relationship will solve. But there are situations like the project guide, where it is naturally non-binary. You cannot have a relation between instructor and project, or instructor and student, student and project. Those none of them represent the reality of instructor, student, project being together. So, in those cases it becomes difficult to, I think I skipped one. Yep. So, here is a situation. So, these are some of the approaches of analyzing or representing through alternate. So, here is what I have here is a ternary relationship between A, B, C. What you do, you can create, you can represent this in terms of binary relationship by introducing a new entity set E with an identifying attribute. What is the E? Just as a primary key. It could be a synthetic one. Right? So, you have E sitting here, coming in here in place of where R was, and you have now 3 decomposed binary relation R A, R B, R C. Right. So, here what did you have? You had A I, B I, C I, the triplet in this case. So, now you add E I A I, E I B I, E I C I respectively to here, here and here. So, using E I, you will be able to recombine and get the triplet information back, and using the triplet you will be able to go from the ternary to the decomposed binary relation. Right. So, it is information preserving, it has the same information. Right. But this is not all. What you need is also need to translate the constraints, and translating all constraints may not be easy, because when you are in a binary relation, you know the information about 2 entities. So, if you have constraints which actually involve all the 3 entities, that cannot be directly enforced on the decomposed binary relations. Right. So, you have to change the constraints and think of how you can check for what you are needing to do. Further is we can also avoid creating the identifying attribute by making E a weak entity set. So, it is a weak entity set which has no attribute. Right. So, this is because that is the basic role, is just to relate. Right. Now, these are some of the key design decisions you need to take for entity relationship model, entity relationship design. Use of attribute or entity set for representing objects. What should be good as entity set and what should be good as relationship set, and there is no universal rule for them. Maybe some thumb rules, but it is more of judgment, experience and quality of design, and often designing this way or that way may give 2 equally good alternates. The use of ternary relationship versus pair of binary relationships, we have talked about this. Use of strong and weak entity sets, these are the key design areas. So, when you do the design, focus on these and ask yourself, I am using this, is it okay or should I have used the other? Use of specialization, generalization, which significantly helps in the modularity of the design, because you are not cluttering all things of student and all things of employees with everything of person. Student side gone, employee side separate, person's general side separate, much more modular in that way. Use of aggregation, where aggregated entity can be, so it is kind of a hierarchical conceptualization that you are doing. You are aggregating stuff together and creating a new concept of an entity through the relationship interactions that are happening. So, these are some of the key considerations of entity relationship logical design. So, as we go through the tutorial and exercise, you will slowly start getting more insights into that. Remaining couple of slides are for your reference. So, where we have put the symbols that are used in ER notation. These are significantly from UML, but does not mean that you have to go and open up UML books, do not try to do that. But these are these are not only, it is not that we are following this notation or this book is following the notation. The advantage of this notation is kind of universal and standardized, internationally standardized. So, you use it in any company, in any organization, it should be recognizable in the other. So, entity set relationships, all of these we have seen. I mean, we have tried to cover all the meaning of all the notation and the consequences of that. So, you should be able to see through this. Of course, here there is an alternate. You can see that like a blooming tree, you have the E is entity and A1, A2 are attributes, and then they are shown in terms of their composition. The is A is shown in a different way, and so on. So, these used to be the earlier representation. For decades this representation has been used, but so you will see that in several places in books and internet, but do not use it afresh because people have moved on from here and so on. So, these are the alternates that exist in other system, the chain, so on. So, these are we are not suggesting that you use it, but we have given it here so that if you get some design, so that you will be able to understand, okay, it is in this notation. So, read up on that notation. Okay, so, we have with this we are completing the discussion on the extended and total features of entity relationship model as we need. We have talked about a few design issues. We will continue to discuss this, and thank you very much for your attention, and we will take up new aspects of database design in the subsequent modules.